Since the final Apollo 17 mission, the entire world has waited with hope, wonder, and growing anticipation for the moment when humans would once again set foot on the moon. That moment might finally be within reach. NASA's Artemis 3 mission, currently set for launch in 2027, carries the dream of a new lunar era. Powered by SpaceX's Starship HLS, Artemis 3 plans to take humans back to the moon after over 50 years. But that dream is not without its obstacles. Starship HLS is currently facing major delays and tough technical challenges, raising serious questions about its readiness. NASA's ambitious Artemis timeline is ticking like a countdown clock, and with every passing month, doubts are beginning to spread. People are wondering if SpaceX can actually meet the deadlines. Meanwhile, China isn't sitting idle. They're rapidly advancing their own lunar program, building momentum with every step. Their efforts are now raising a critical question. Could China reach the moon before the United States does? The global space race is heating up again, and today's episode of Alpha Tech dives straight into this growing competition, looking at where things really stand for NASA, SpaceX, and their biggest international rivals. While a lot of attention is focused on the upcoming Blue Origin and S-31 flight, something more urgent is happening in the background. What many people don't realize is that NASA is under immense pressure to stay on schedule. Behind the scenes, teams are racing against the clock to prepare for Artemis 2, the first crewed mission of the Artemis program. That mission is scheduled to launch around this time next year, and the work is already full steam ahead. At the Kennedy Space Center in Florida, the powerful Space Launch System rocket is now being stacked inside the legendary Vehicle Assembly Building. NASA is shifting all of its attention and resources toward Artemis 2, and the momentum is clearly picking up. Teams are working day and night to make sure everything stays on track for that crewed flight. But on the SpaceX side, the situation looks less reassuring. They've landed massive billion-dollar contracts to develop the human landing system for Artemis 3, yet there has been a noticeable silence. No official updates, no major announcements, and no real word on the progress of Starship HLS. Even more concerning, there's been no visible movement on the orbital propellant depot, a crucial part of the mission. As the clock keeps ticking, anxiety is growing. Even the most loyal SpaceX supporters are beginning to ask tough questions. Why is there so much silence? Is everything truly on track, or is something being hidden? So far, SpaceX's support of NASA's Artemis missions hasn't lived up to expectations. Although they've completed 8 test flights of Starship, the outcomes have been mixed at best. Earlier this year, 2 back-to-back explosions during Flight 7 and Flight 8 sent shockwaves through the space community. These high-profile failures didn't just disappoint NASA, they also rattled confidence among key players like the Department of Defense and major investors. However, it's not all doom and gloom. These explosions, while dramatic, have actually led to valuable progress. Across all the test flights, SpaceX has gathered a huge amount of critical data. They've made meaningful design improvements, especially in how the Super Heavy booster is caught using the chopstick arms. They've also been working on reinforcing Starship's overall structure. One big improvement came after Flight 4, when overheating damaged the aerodynamic flaps. SpaceX responded by strengthening those flaps with heat-resistant materials and changing the re-entry angle to reduce thermal stress, showing how quickly they learn from mistakes. Another serious issue that surfaced involved the heat shield tiles. During Flights 3, 4, and 5, several of these tiles detached mid-flight. This posed a serious risk to the vehicle's integrity during re-entry. But once again, SpaceX didn't sit still. They immediately took action to improve the quality of the tiles and strengthen the attachment methods to prevent future incidents. These upgrades are now being integrated into future missions. More importantly, the 2 recent explosions helped SpaceX identify a critical flaw known as harmonic response, a dangerous condition where vibrations build up abnormally, putting excessive stress on propulsion systems and other key hardware. Despite these challenges, the lessons learned have been incredibly valuable. Every failed flight, every broken part, and every unexpected event has helped build the foundation for Starship version 2. With that progress in mind, SpaceX is now focused on testing the powerful new Raptor 3 engines in upcoming flights. Their goal is to gather enough reliable data from 5 to 10 additional test launches. Once that's done, they'll be ready to introduce Starship version 3. This upgraded version will be specially adapted to serve as a tanker and as the orbital refueling depot required for Artemis 3. SpaceX knows exactly what they're doing. They're moving carefully, step by step, using each test to sharpen their designs and systems. There's real strategy behind the apparent silence. If you look closely, the signs of progress are everywhere. For example, let's talk about the ongoing upgrades at Starbase. There's growing speculation that Pad B is being designed as a movable system. If true, that would mean SpaceX could quickly repair or replace it after each launch, supporting their bold goal of launching one Starship per day, or even faster. What seemed crazy at first is now starting to make practical sense, based on what's happening on site. Recently, a mysterious part was seen heading toward Pad B, and its bolt holes matched up exactly with a mount that was spotted back at the construction site. That part is now confirmed to be the launch mount support legs. Interestingly, they're being bolted together underneath Pad B. This setup suggests that the structure is currently fixed, not mobile yet, but the fact that it's bolted rather than welded opens up the possibility of future upgrades or even modular replacements. It's a smart design that leaves room for flexibility, which is crucial if they want to speed up the launch cadence. At Pad B, more upgrades are clearly underway. The flame deflector has already been installed deep within the trench. Now, the teams are busy laying down large green pipes, which are part of the massive water deluge system. This system is essential to cool the pad and reduce the extreme heat and vibrations generated during launch. The deluge system is divided into two main parts. One set of 5 tanks sprays water from above the pad, while another set of 4 even larger tanks dumps water directly into the flame trench. That's how they manage the sheer intensity of 33 Raptor engines. When those engines fire up, the sound and pressure are so powerful they can literally shake the ground and melt nearby structures. That's why the water system is so crucial. It not only helps protect the pad itself, but also keeps the surrounding environment from getting damaged. If all goes according to plan and construction stays on schedule, Pad B should be fully operational by the end of this year. That means SpaceX could be ready to complete the remaining 23 test flights needed before 2026, keeping them well within reach of supporting the Artemis 3 lunar mission. The year 1972 marked a turning point in human history. It was the last time humanity set foot on the moon, a monumental feat that has echoed through the decades as a symbol of what's possible when innovation meets determination. Since then, space agencies have conducted countless test flights, advanced rocket technology, and designed futuristic spacecraft, but none of them have actually landed humans on the moon again. All those test flights, no matter how impressive, have remained confined to Earth orbit. None were ever built to be true moon landers. That's what makes SpaceX's current project so exciting, because finally, we're seeing the potential return of humans to the moon becoming very real. Prototypes are now inching closer to reality. So far, most of what we know about the Human Landing System, or HLS, comes from detailed mock-ups. These include both interior and exterior models, giving us a glimpse into what astronauts might experience. These mock-ups aren't just for show, they're critical for visualizing operational elements, crew mobility, and equipment layout. What's immediately obvious is how different the HLS is from the standard Starship variants that we're used to seeing. Unlike the orbital versions of Starship, which require a heat shield and aerodynamic flaps for Earth re-entry, the HLS won't need any of those. Why? Because the moon doesn't have an atmosphere, so heat shielding and flight control surfaces are simply unnecessary for lunar missions. Instead, SpaceX has equipped the HLS with specialized landing legs. These are essential for stable and safe landings on the lunar surface. And when it comes to engines, the HLS won't use the standard Raptor engines either. It will feature specially optimized Raptors designed specifically for the moon's unique environment. These engines will have finely tuned thrust controls to minimize dust disturbance during landing, a major concern when touching down on the lunar surface, where even small amounts of kicked-up regolith can cause big problems for equipment and visibility. But developing the HLS alone won't be enough to meet the demanding requirements of NASA's Artemis mission. The full picture is much more complex. SpaceX also needs to design and build 2 additional systems, a Starship tanker and an orbital refueling depot. These components are absolutely vital to completing the Artemis mission successfully. That's because the HLS is incredibly heavy. It needs to carry a lot of fuel to not only reach lunar orbit but also pick up astronauts, land them on the moon, and return them safely to orbit. That kind of journey requires an enormous amount of propellant. To achieve that, SpaceX will need to master in-orbit refueling. The tanker spacecraft, based on Starship version 3, will be the workhorse for transferring fuel in space. Interestingly, this tanker won't have flaps or a heat shield because it will remain in space, transferring fuel from one orbiting spacecraft to another. Meanwhile, another tanker variant that's designed to return to Earth and be reused will require both flaps and a heat shield, making it more robust. The goal is to create a fully reusable fuel supply chain in orbit, something that's never been done before at this scale. To increase the total fuel each tanker can carry, SpaceX is exploring a few design strategies. One option is to add large auxiliary tanks in the payload section, giving the spacecraft a bigger internal fuel reserve. Another approach could be to extend the main tanks to use more of the available interior volume. These design tweaks would dramatically boost capacity, enabling fewer launches for each mission, which saves both time and cost. Many believed these tanker variants would debut at the same time as the HLS. But then Elon Musk dropped a surprising update in early March. In that announcement, Musk revealed something few expected. There's a good chance of achieving full reusability of Starship this year, he said. Not only that, but he also added that full and immediate reflight of Starship, combined with orbital refueling, will probably happen next year. That's a massive claim. If true, it would represent a giant leap forward. And with Artemis 3 currently targeted for 2027, that timeline suddenly makes orbital refueling look less like a long-term goal and more like an imminent breakthrough. We could witness the first orbital refueling well before the Artemis crew even launches. SpaceX isn't wasting any time. They're accelerating development on multiple fronts, at their Starbase facility in Texas and at their headquarters in Florida. Infrastructure upgrades are happening quickly. At both Launch Pad A and the newly prepared Pad B, production facilities are being expanded, new platforms are being installed, and test equipment is being upgraded. Once these setups are fully operational, testing frequency is expected to increase dramatically. All of this signals that SpaceX is treating Artemis and the HLS with top priority. The dream of a fully operational lunar lander by 2027 is still alive, but only if SpaceX can maintain this frantic pace and complete the necessary design, testing, and refinement on time. However, there's a growing concern. If delays happen, and in aerospace they often do, there's a real risk that China could beat the US back to the moon. And China isn't playing around anymore. They've dramatically accelerated their lunar ambitions. Originally, China's plan was to land humans on the moon by 2030. But now they've shaved an entire year off that schedule. They want to land by 2029. And they've already started laying the groundwork to make that happen with their Long March 10 rocket, a powerful new system that's being built to match the capabilities of America's best. The Long March 10 comes in multiple versions. The first variant is aimed at supporting the Tiangong space station in low Earth orbit, ferrying the next generation of crewed spacecraft. This version stands at 67.4 meters tall, with a 5-meter wide core. It can launch payloads of up to 14,200 kilograms, and notably, it's equipped with a booster recovery system. That feature mirrors SpaceX's own approach with Starship, highlighting that China is adopting and improving on reusable launch technology. But that's just the beginning. The lunar variant of the Long March 10 is even more impressive. This version will be a 3-stage behemoth standing 92 meters tall, larger than the current Block 1 version of NASA's SLS. It's designed to send up to 27 metric tons directly into translunar injection orbit, putting it squarely in competition with NASA's own heavy lift systems. And here's the kicker. It could be partially reusable, which means China might end up with a more cost-efficient lunar system than the US. That's a serious game changer. And China's strategy goes even further. Their plan for the lunar mission involves not one but 2 Long March 10 rockets. One will carry the crew module, called Mengzhou, while the other will launch the lunar lander named Lanyue. The 2 spacecraft will rendezvous in lunar orbit, just like the US did with Apollo's command and lunar modules. The astronauts will transfer to Lanyue, descend to the lunar surface, spend approximately 6 hours exploring and conducting experiments, and then return to orbit to reunite with their 3rd crew member, who remains aboard Mengzhou. It's a bold, Apollo-style mission but built with modern technology. The timeline is already in motion. The first Long March 10 test flight is scheduled for 2026. In fact, China has already conducted a successful static fire test of the rocket's engines back in June 2024. And the dedicated launch pad for the mission? It's expected to be fully operational by 2025. This isn't just a dream or a concept drawing, it's a real, physical infrastructure project already deep in construction. China is investing heavily in this mission and moving at a pace that few expected. It's no longer a question of if, it's when. But China's ambitions don't end with landing astronauts. They're thinking long-term, very long-term. Between 2033 and 2035, China plans to go even further by building a nuclear fusion power plant on the moon. Yes, you heard that right. While NASA hopes to launch a similar system sometime in the early 2030s, China is already taking the first steps to make it happen. On April 23, a top Chinese space official publicly confirmed these plans. If successful, it could allow them to generate massive amounts of energy directly from the lunar surface, potentially powering future bases or even beaming energy back to Earth. So here we are, watching two titans, SpaceX and China, race toward the moon at full throttle. The question is no longer about capability. It's about urgency and execution. Can the US keep up? Can NASA and SpaceX move fast enough to retain the lead? The truth is, this is no longer a hypothetical or long-term rivalry. It's a real competition happening now, with national pride, global influence, and scientific progress all on the line. And if the US falters, the next flag planted on the moon might not be red, white, and blue. But that outcome isn't guaranteed, not yet. NASA still holds the legacy of Apollo. It's the only agency that's ever landed humans on the moon and returned them safely. That legacy carries weight. And SpaceX, they're pushing the boundaries of technology and speed like no one else. Their vision, their drive, and their raw engineering talent give the US a fighting chance. The clock is ticking, the stakes are enormous, but the race is far from over. The path to the moon is still wide open. And now, more than ever, it's about one thing. Asterisk, who wants it more, asterisk.